All right, 4.2a, this is the worksheet for it. They want you to find the vertex, axis of symmetry, maximum value, and the range. So the first thing you want to do is you want to identify what kind of form the parabola is in. This is in standard form. So in order to find the vertex when it's in standard form, the vertex is going to be at opposite of b over 2a, comma, f of the opposite of b over 2a. Okay, so let's find out what the opposite of b over 2a is. If a is 1 and b is positive 2, we're going to take those and we're going to put those in. So the opposite of b over 2a, that's negative 2 over 2, which is negative 1. So the x-coordinate of the vertex is negative 1. To find the y-coordinate of the vertex, you have to take this value and plug it in for x. So basically you want to find the value of the function when x equals this here. So in other words, when x equals negative 1, what's the value of the function? So we're going to go in, substitute negative 1 in for x, and simplify and see what we get. So y equals 1 minus 2 minus 3. So y is negative 4. So that's my k. So this is part of my answer here. Now they want to know the axis of symmetry. Well, the axis of symmetry is always x equals the x value of the vertex. So it's x equals 1. Max or min value? Well, a is positive, so it opens up. If the parabola opens up, it's going to have a minimum value since it bottoms out. So the minimum value is going to be whatever k is. It's always going to be k. And the range is going to be the set of all y's such that y is greater than or equal to, because it's opening up. If it opens up, the range is going to be greater than or equal to the minimum value, negative 4. And that's your answer. Number 2, they're asking you the same things. They want to know all of those things: vertex, axis of symmetry, so on and so forth. For number 2, it's a little bit easier because there's no x value here. You can write it out having an x value if you want. You could write down plus 0x plus 3. And then when you try to find the vertex, it's going to be the opposite of b over 2a. So that's going to be 0 divided by 4, which is 0. So the x coordinate of the vertex is going to be 0. When I plug in 0 in here, it's going to eliminate all this, and it's going to eliminate all that because we're multiplying by 0. So it's just going to be 3. 0 squared is 0. 0 times 2 is 0. 0 times 0 is 0. I'm saying 0 way too many times here. 0 plus 0 is 0. 0 plus 3 is 3. So there's our vertex. This number, I refuse to say it, comma 3. There's your vertex. They also want to know what the axis of symmetry is. So the axis of symmetry is going to be, remember, it's an equation of a line. So x equals that value that we're not going to name. It almost sounds like the numerical version of Voldemort. It's my Harry Potter joke for the day there. Okay, what else? Maximum or minimum value. Okay, so is it going to have a max or min? Well, my a value is positive. If it's positive, just like number 1, it's going to have a min value. So my min value is going to be 3. It's the k. It's the y value of the vertex. And they want to know the range. So the range is going to be the set of all y's such that y is greater than or equal to 3. Greater than or equal to because it opens up. Okay, number 3. They want to know the vertex. So let's do it out. The opposite of b divided by 2a. Remember, here's your b, here's your a. So the opposite of negative 3 is 3. 2 times negative 2 is negative 4. So that is your x-coordinate of the vertex, negative 3/4. So to get your y-coordinate, you have to input negative 3/4 for x. You have to substitute. So y equals negative 2. Whenever you substitute, use parentheses. Negative 3/4 squared minus 3 times negative 3/4 plus 4. Gotta love fractions. Y equals. So we want to do this first. We want to do exponents first. So we'll leave this negative 2 here. Negative 3/4 squared is 9/16. Negative 3 times negative 3/4 is positive 9/4 plus 4. Okay, so negative 2, you can write it as negative 2 over 1 if you want. Negative 2 over 1 times 9 over 16. This 2 and 16 can cancel to an 8 down here. So we're going to have negative 9/8 plus 9/4. Well, what I'm going to do is I'm not going to write it as 9/4 because at this point in the game, we're adding and subtracting fractions. When you add and subtract fractions, you always want common denominators. So this 8 over here is going to set the precedent for what the denominator should be for these. So what I'm going to do is I'm going to make this 4 into an 8 by doubling it. Whatever I do to the denominator, I got to do to the numerator. So I'm going to make that 18. Now this 4 has a denominator of 1. I'm going to multiply that by 8 to get eighths. That means I got to multiply that by 8 to get 32. So all of that is going to add up again to eighths. Negative 9 plus 18 is 9. 9 plus 32 is 41. So here's our fraction. This is our output. So there's your vertex. They also want the axis of symmetry. So the axis of symmetry is the equation x equals h, or x equals negative 3/4 in this case. They want the max or min value. It opens down since a is negative. That means it's going to top off, so it's going to have a max value. So it's going to have a max value equaling 41/8, or 5 1/8. And it also wants the range. So the range is going to be the set of all y's such that y is less than or equal, because it opens down, to k, which is 41/8. Alright, number 4. They want you to graph this function. Well, in order to graph the function, if you remember from my explanations from 4.1, it's always good to get, ideally, the vertex. So what we're going to do is we're going to find the vertex, plot that, and then go from there. So the vertex is the opposite of b over 2a. So the opposite of negative 5 is 5. 2 times 2 is 4. So that's our x coordinate of the vertex. The y coordinate is going to be the value of the function when I substitute 5/4 in for x. So it's going to be 2 times 5/4 squared minus 5 times 5/4 plus 1. So 2 times 5/4 squared is 25/16. Negative 5 times 5/4 is 25/4 plus 1. Over here, we can cancel the 2 and 16 and make an 8 down here. So what I'm going to have now is 25/8 minus, I'm going to make this eighths again. I'm going to multiply the denominator by 2, the numerator by 2. To make 1 into eighths, it's 1 over 1, remember. Multiply the bottom and top by 8. So 25, remember it's going to be over 8. So 25 minus 50 is negative 25. Negative 25 plus 8 is negative 17. So there's my vertex. So let's plot that. 5/4 is 1 1/4. And I'm going to go down negative 2 1/8. So it's like going to be right around there. It's like such a small graph. So negative 1 1/4, comma, negative 2 1/8. So there's my vertex. It'd be good if I had another point, and I do. This right over here is your y-intercept, so positive 1. So I'm going to graph that point right here. Now to find the point that's symmetric to it, I have to calculate the distance horizontally from this point to the axis of symmetry. Remember, this is not at 1, it's at 1 1/4. So it's a distance of 1 1/4 here. So if that's a distance of 1 1/4, I want to add 1 1/4 to 1 1/4 to get the other point. So 1.25 plus 1 plus 2.25, if that made any sense, is 2.5. So you're going to have a symmetric point right here. So you can graph it using these points, or if you want a more accurate graph, you can find out what happens at like 4 or somewhere further than that. So just going to do a rough sketch here. That's roughly what the graph looks like. Number 5, write the function in vertex form. Alright, so in order to get vertex form, you could have y minus k equals ax minus h squared. We need 3 things. We need a, we need h, and we need k. So in other words, we got to find out what the vertex is here. So the opposite of b over 2a, negative 8 over negative 4 is 2. So my vertex is going to be 2 comma something. Let's plug 2 in up in here to find out what it equals. So y equals negative 2 times 2 squared plus 8 times 2 plus 3. Y equals 2 squared is 4. 4 times negative 2 is negative 8. 8 times 2 is 16 plus 3. Negative 8 plus 16 is 8. 8 plus 3 is 11. So my vertex is 2 comma 11. So we have h, we have k, and we have a right there. Remember, the a in the standard form is the same as the a in the vertex form. So let's plug them in. So y minus k, which is 11, equals a, which is negative 2, times x minus h, which is 2, squared. And there is your equation of the graph. Or of the graph that hasn't been graphed yet, but it's the equation of the parabola. Alright, number 6. The vertex of the function is given. So here's your vertex right here. They're giving that to you. You have to find out the unknown coefficients, the unknown of B and the unknown of C. So what we're going to do is we're going to use the fact that we know that the opposite of B over 2A equals the x coordinate of the vertex. Well, if we're already given the x coordinate of the vertex, it equals 1, so we can say that it equals 1. In addition to that, we know what A is. A is -3. So we can take that -3 and substitute it for A. So we're going to have the opposite of B over 2 times A, which is -3, equals 1. From there, we can say the opposite of B over -6 equals 1. Negative B over -6, the negatives cancel, so you just have B over 6 equals 1. Therefore, if you multiply both sides by 6, B is 6. So, let's put 6 in for B and see where we're at. Alright, so we're one step closer. We still don't know what C is. But if we input these values for x and y, because it is a point, even though it's a vertex, it is a point on the graph, we can use this again for x and y, x being 1, y equals 0. So let's put those in, x being 1 and y being 0, and solve for C. 1 squared is 1 times -3 is -3. 6 times 1 is 6. So we have 0 equals, oh, I said the word. Darn it. Alright, 3 plus C, that means C is -3. So we've got B, we've got C, and we're all set. Number 7, review problems. Number 7, they want you to solve the system. Now, there are 3 ways of solving these systems that you probably learned in Algebra 1. The first way was elimination, where you multiplied either the top equation, the bottom equation, or both equations by something, so that when you added down, one of the variables would cancel so that you could solve for the other variable. The second method was substitution. So method 1 was linear combination or elimination. The second way was substitution, where you would either solve for x or y in one of them, and then you would substitute it in for the other equation. Or you would graph both of these on a coordinate system and find out the point of intersection. Graphing is the worst of those 3 because sometimes the graphs don't meet at a point that has, integers for the values of x and y. So, I mean, x could be 1 and 1/32. 33 over 32 could be the value of A. How are you going to interpret that on a graph? Nearly impossible, if not impossible. So we're going to stick with either one of these 2. What I'm going to do on this one is I'm going to use elimination. I'm going to multiply the entire bottom by -3, so that I'm going to get this y term being -3y, so that when I add down, these are going to cancel because a positive 3y and a negative 3y cancel. So let's rewrite the top equation. And then the new bottom equation is going to be -3 times -5x is 15x. -3 times y is -3y, which is exactly what we wanted. -3 times -13 is 39. Now we add down. The adding down is going to eliminate the y terms. 17x equals 51. Divide by 17. x equals 3. So if x equals 3, we can stick 3 into x in either equation. So 2 times 3 plus 3y, this is the top equation, equals 12. 6 plus 3y equals 12. 3y equals, subtract 6 from both sides, divide by 3, y is 2. So the point of intersection, which is the solution of a system of equations, it's either a point or multiple points, but both of these are just straight lines, so it's going to be one solution for this one. Technically, you could have infinite solutions or no solutions if they're parallel lines or if they're the same line. But we have one point of intersection. It's at 3, 2. That's your solution. That's your answer. All right. Number 8. Write the equation of a line that's perpendicular to that and also passes through the point. So perpendicular gives you a clue for the slope. That means the perpendicular line is going to have not the same slope as 4, but the opposite reciprocal. So first you want to find the reciprocal of 4, it's 1/4, and then you take the opposite of that, negative 1/4. So that means that's your slope. So y equals negative 1/4 x plus b. So we can find out what b is by using the point here. This is your x and y. We can substitute those in. So 6 equals negative 1/4 times 2 plus b. 6 equals 2 times this. The 2 and the 4 can cancel. So you're going to have negative 1/2 plus b. And if you add the 1/2, you get 6.5. So putting it all together, we get y equals negative 1/4 x plus 6.5. Write it as an improper fraction, and you get that. Another way you could have written this is in point-slope form. Because you have a point, you have a slope, might as well use it. So y minus y1, y1 is 6. So y minus 6 equals the slope times x minus x1, which is 2. This is also acceptable. One's written in mx plus b, the other one's written in point slope. Number 9, write the equation of the line that passes through the points. So they give us 2 points of a straight line. Might as well solve for the slope. So 2, which is y2, minus y1, which is 9, divided by x2 minus x1. So negative 7 over negative 7 is 1. So there's your slope. So let's just write this in point slope. So we could have 2 separate answers. So y minus y1, I'm using the first point here, equals the slope 1 times x minus x1. That's a good answer. That's a correct answer. Use the other point now to get a different answer if you'd like. Y minus y1, which is 2, equals 1, the slope, times x minus negative 5. You get x plus 5. And there's your answer. Either answer is correct. And number 10. Write out an explanation describing how you can use the axis of symmetry to help you graph a parabola. So, to use the axis of symmetry, let's just say that here's our coordinate system. Let's say my vertex is right over here. That means my axis of symmetry is going to be the vertical line that goes through that. Goes right through it. I'm going to draw the vertex a little bit bigger here. How do we use that axis of symmetry? Well, if the axis of symmetry goes through the vertex, then the points occurring to the right of it. Let's say the points, let's say you've got a point here, and then a point here, and then a point, I don't even know, way up here. Let's say those are your points. You can use the axis of symmetry almost like you would if you were painting a butterfly. I use this analogy in class. If you're painting a butterfly on a sheet of paper, I mean, let's say this is your sheet of paper, right? And someone wanted you to draw the quickest butterfly in the world. Don't bother drawing the entire butterfly. Just do this. And then what do? Fold the piece of paper over and then unfold it. What happens? All of this stuff over here gets... This is a sweet butterfly. Look at this. Wow, that is impressive. I've just impressed myself. Sorry. Yeah, you do one side of it, and in doing one side of it and folding it along a line of symmetry, you've basically done, not basically, you have done the other side. So use the symmetry. So if there's this point at this distance away from the symmetry line, then you're going to have the same point on the other side. This distance away, same height. This distance away, same height. This distance away, that distance away. Then you can just go right through and you've got your parabola. That's how you can use an axis of symmetry. Now when you write out the explanation for this, don't write out the fact that I'm such an awesome butterfly drawer, because that really is like a side note, even though that should be obvious to everybody. That's a side note. So just write out, the math part of it. And that's it. Sorry that it took this long for this video, but I don't know, I'm actually making it longer by rambling right now. But it's long not because of my long-winded stories about butterflies and how awesome I am at drawing them. It's long because of the opposite of b over 2a and then plugging it back in. It takes a little bit of time in order to calculate the vertex, but it's all worth it in the end. And that's it. Till next time.